kilometers, some are 2 kilometers long valleys, which contain lot of different sediments. Which these diagrams make how the sediment has been deposited in these valley systems. So peat, sandy peat, silt, like fine grained sediment, all kind of sediments there. So this is the usual archives we use. Within these archives, we made a palynological investigation as a main proxy. These are the main pollen types what we found: Lorambergia, this Eugenia, Calophyllum types, which are very indicative of climate factor. For example, the Calophyllum, which is the one of the dominant tree species growing in the montane rainforest, which is very much indicative of climate. And Eugenia also same. Lorambergia is an aquatic plant, which is also very much indicative of hydrological system. And the rhododendron and the moss, sphagnum moss, which is very sensitive and very much indicative of a climate change. So that's we use to measure climate change. This sphagnum moss pollen. And of course, another important thing is amoeboid cyst, which these sediments and peat sediment and some other type of sediment what we found there, they contain a lot of amoeboid cyst, which is a good indicator of the moisture changes. So we use as a proxy there. Instead of that, in inorganic fossil like phytolith, which is a silicate fossil, the plant they absorb silica, and the silica deposited within the plant or in between cells or intercellular space as a particles, which is called phytoliths. These phytoliths also very much important proxy for understanding paleoclimate or climate change, even though human activity and vegetation change and other things also. This kind of phytoliths preservation is excellent in this sequence. Then pollen, of course, this phytolith we can group according to their morphotypes and morphological changes. Usually panicoid grass, they produce particular type of phytolith. Chlorodoid type grasses, they produce another particular type of phytolith. Both are C4 plant. Everybody familiar with the plant systems. Usually grasses, they divide into 3 systems: C3 plant, C4 plant, chem plant. These plant systems are excellent indicator for understanding the climate and environmental changes. The C4 plant, usually they produce panicoid and chlorodoid type phytolith. Usually chlorodoids, they grow in the very arid areas, arid climatic conditions. But panicoid, they prefer much water. They need more water to grow. So in that sense, these two types of phytoliths are very good indicator of the moisture changes and aridity changes. So we use this to measure climate change. Aridity index is of course called the chlorodoid panicoid phytolith ratio. How many phytolith we found in each samples, and we can measure the ratio between chlorodoids and panicoid in between. The ratio between these two, which is excellent indicator of the aridity. So other type of grasses so we also found there. This also tells something about climate change. Anyway, this is the new proxy in our part of the world. Usually some other areas like high latitude areas, they also use this proxy for climate change. It is much better. We're working the phytolith in African-like countries, Africa-like countries. They have very good, excellent record for phytolith based climate record. Instead of that, another proxy we use the diatoms. The diatoms also gives some information about climate change. But we found number of different diatoms there in our samples, our cores, like Aulecoseria livissima is one of the key diatoms what we found. They are planktonic diatom. Instead of that, Eunotia, some other type of diatoms, which also prefer some wet conditions or environment, wet environment, or some certainly humidity. But Aulecoseria livissima is a particular diatoms which usually grow in the water columns or high water levels. These lakes, usually they contain this diatom. So anyway, we use this kind of diatoms and phytolith for reporting our climate change. And another important thing is what we work in the paleoclimate science is age depth model. In our course, we have taken several cores for analysis. I told you basically 4 cores. All these cores we made the cores dated by the radiocarbons, Ames radiocarbons. And every course we have to make some kind of age depth model. The age depth model which gives some ideas about how the accumulation pattern change. So this diagram also indicates some certain ground about how the accumulation pattern changed during the last 24,000 years in our course. So this diagram clearly say from the beginning it was 24,000 to 10,000 years something is gradually changing this accumulation pattern. Is very rapid accumulation going on around 10,000, 9,000, and again accumulation is slightly decreasing and it come to the minimum level somewhere there here, and again accumulation pattern is increasing. This sediment accumulation pattern, which is very good indicator or very good another process climate change. This columns will tell us something about this accumulation thing. Age depth model, which is now very fascinating business in the modern world. Different programs use, different scientists, they use different programs for making age depth model, but we use some simple model for that. This is the thing. So this is our results. I would happy to give some idea about the result. This is the pollen accumulation. These diagrams include the pollen accumulation and pollen accumulation rates in each line. I hope you can see in the age my core is going along from 0 to 24,000, and lithology is changing from different lithological changes, organic clay and then peat. Peat is accumulating from here up to there, and then it's a depositional time, that is how many years take place in the 1 centimeter deposition. So this is accumulation rate. In the opposite, the accumulation rates. And then next column tell us total pollen accumulation rates. And then next column tell us how it's changing the upper montane rainforest. You can see here each per cubic centimeter, how many pollen grains in each level, how its changing pattern is through. And the numbers tell us something about the particularly how many typical rainforest taxa found in each level. Typical rainforest taxa, we didn't find anything in the lower part, and one taxa very minimal. And then here is a 35 taxa we found here, it's up to 45, and 55 is a minimum level around 9K thousand and 70,000, and again a 0 taxa found, and then something increasing here. The pollen accumulation rate, you can see here total pollen accumulation rate is varying, very minor patterns here, something up to this level, and is rapidly changing, very rapid accumulation going in here, and very rapid accumulation again on this part, and slightly is decreasing. The accumulation rate is largely changing with this core. Here is very slow accumulation and again slow, and something is getting relatively low and maximum, and then it's in decreasing, and then again decreasing and maximum level. Something like this is changing pattern. You can see the wetland pollen. The pollen, like I told you, wetland grass, wetlands. This is also. Wetlands is changing, and the grasslands and pteridophytes like Cyanathrya sinnata, which is very much indicative species of the climate, and macrofossil like moss, it's quite heavily changing in upper part of the thing, and very little moss accumulating here and again here, and nothing there. And this Pinus like pollen is a long distance transportation pollen. Anyhow, based on this, we made a how the climate has been changed. In the lower part of climate is mostly very little rainforest pollen found there. We interpret in terms of these pollen records and others in very dry climate, a series of dry climate up to there is the LGM climate. LGM climate is dominated by the very arid and semi-arid climate, and then it's starting in the wet condition. And similarly, this blue color tell us something how the moisture or how the monsoon is strengthening times is this blue color, and the gray color is like monsoon weakening time. You can see here a lot of arid phases are coming up, the yellow color, and the blue color is something monsoon strengthening and monsoon weakening. And upper part of very much changing pattern going in rapidly. Climate has been changed there. Blue color is certainly wet phase, and other yellow color, gray color indicates something dry phases. Wet and dry phases. Number of wet and dry phases repeat. Here is very much repeatedly occurrence of the dry and wet phase repeatedly occur in this area, around 9 to 10,000 BP. So this kind of climate changes happen. And another important thing in this diagram will about mineralogy. The mineralogy changing clay minerals and coarse clay, microclay particles, and the mineralogical changes. You can see these clay minerals, how it's increasing, and this is also fine coarse clay mineral. This is a coarse sand. This is a mineralogical change. This here something very specific changes going on this here and here and here. So this is we found a lot of pollen there, and we call it a rainforest expansion time. This is also mineralogy respond at that time, increase in peak and again decreasing. And here is something happened near to Holocene, early Holocene phase, rainforest maximum there, a lot of pollen found there, and this is 10 to 9K, and the rainforest is decreasing. So this is some way incorporate with the pollen record. So this record tells us something about other two, three parameters like a diatom, which is quite heavily found in this area. At that time, we found a lot of planktonic diatom near to 10,000, 9,000, 11,000, 10,000, 9,000 in between period. And again, it's decreasing. Here is no diatoms found there, quite a lot. And other panicoid and chlorodoid phytolith is quite heavily varying, and the bottom part is dominated by chlorodoid phytolith, which is usually grow in the dry climate condition, and panicoid is usually prefer wet and is dominating in this part of the world and this part of the core, and then increasing both slightly in proportionally. And another parameter we use in the proxy, we call it delta carbon. The delta carbon also gives some certain idea about the vegetation and climate, and this part of this minus 28, 24 is changing here, and it's changing 10 to 15 here, and 10 something. This indicates C4 plant community, and here it's dominating C4 plant community, and C3 and C4 plant community. No, usually C4 plant community, they produce chlorodoid phytolith under dry climate conditions. Another parameter we use is the remnant magnetization. Is a magnetic property of mineral, is highly variable in this highly variable in this red band area, which is this correlate with this, and is getting low. So then it's coming into the conclusion, and this sequence tell us something about the paleoclimate record like this. Horton Plains, which provide the last 24,000 paleoclimate record. LGM is highly variable with semi-arid and dry climate, is weekend southwest monsoon. The warming is start around 8,000 Ka. From this point onward, ITC is an induced rainfall, or rain started around 15.9, 16.2 in this part of the world. As what we can see, a series of relatively long-term and short-term strengthening of monsoon and weakening of monsoon has been recorded up to the beginning of Holocene. So that is the most important thing. You can see yellow and blue color bands repeatedly occur. Mid-Holocene aridity is significant in our sequence, which is about 4.2 event, also very much reported. And the availability of short-term and short-term event, which is much more apparent and increasing markedly in the late Holocene part, which means the late Holocene is rapidly, the climate has been rapidly changed with dry and short wet phases. So that is the things usually what we did in our core. So thank you very much.
Thank you so much for a nice presentation. I'm really happy to see kind of writing about Indian summer monsoon. I'm wondering, as you say, you have northeast monsoon also reaching in Sri Lanka, right, sir?
Yes.
So especially I would like to know about the 4.2 event. So you have declination, Indian summer monsoon declination has been reported even from Indian subcontinent also. So do you have a visibility of northeast monsoon where also declined during that time, 4.2 event especially?
Yes, excellent. These patterns are completely opposite to the northeast monsoon.